for the purpose, right? Okay, guys, put the heading. Finding the square root of complex number. Finding square root of complex numbers. Just put the heading. Finding the square root of complex numbers. Okay, so finding the square root of complex numbers. So let's see a very interesting lesson today. Finding the square root of complex number. So that means, for an example, I'll start with the easy one. So if there is a complex number 3 plus 4i, I need to find the square root of that. Is it possible to find the square root of complex number? The answer is yes. How to find it? So I'm going to explain the process, right? Okay, guys, listen this. 3 plus 4i. Okay. So the complex number 3 plus 4i and square root of 3 plus 4i. So you know any number in this world can be expressed in the form of complex number. Yes or no? Yes. It can be any number. So square root of 3 plus 4i also must be a complex number, right? X plus I by 4. Then what we do? We say this is z and we say let z equals x plus iy. Understood? So we say this is z and z equals x plus iy. Let's. So we know this complex number and square root of that must be a complex number. That complex number, that square root of this complex number is that. I say that is equal to x plus iy. If I am able to find xn, if I am able to find x and y, then I am able to find the answer, isn't it? Okay. Then what to do? I substitute here. Actually, I square both sides. So I get z squared equals 3 squared, 3 plus 4i. So what is z squared? X plus iy whole thing squared, 3 plus 4i. Right? Then if you expand this, we know how many times we have done. So first one and the last one, minus, that is real one. This one then the x squared and the iy squared, that is minus y squared. And middle one, 2xy into I, that is the imaginary number. This is the real part, x squared minus y squared. And this is going to be 3 plus 4x. So both sides you can equate the real part and the imaginary part. But what we have done the last class, equating the real part. And so we are going to equate the real part both sides. So you'll be having x squared minus y squared, that equals to 3. So one equation, right? So x squared minus y squared, that equals 3. That is the equation 1. And if you equate imaginary part, 2xy. Can you see that 2xy? That equals 4. That means xy equals 2. So that is the second one. Okay, guys, copy this. Then you have to find the x and y. First of all, copy this. Then you have to find the x and y. First of all, copy this. Then you have to find the x and y. Okay. So have you done? Have you copied this? Have you copied this? Yes. Okay. So normally, how to find the x and y using these two equations? So how to find the x and y using these two equations? The normal method is you have to substitute for y or x from the second, and we have to make the you have to make the subject of y from or x from the second equation and substitute here. So we had to explain this is a simultaneous equation, x and y variable. So then you have to substitute one you have to make it in one variable. And sometimes you may end up with the x to the power 4, that is quadratic equation, right? So sometimes you may end up. So, but that is a normal process. But okay, so you can do that. But what I say is first go through my methods first. Then if you fail that, if you unable to do in that method, then you can proceed in the normal way. So just if anytime, if you deal with the square root of these things, definitely please go through my method first, then check whether you are able to do. If not, it takes only within 1 minute you can realize. Within 1 minute you can do also. Then after that you can do normal method. So what is my method? First of all, you have to put like this x and y. First of all, you have to put x and y. See, if you multiply x and y, that is 2. So first you can consider x can be 2 or y can be 1, right? X can be 2 and y can be 1. So substitute here and see whether it's correct. If x is equals to 2, that is 2 squared 4. If y is equals to 1, 1 squared 1, 4 minus 1, 3. Yes, correct. So one solution is x is equals to 2, y is equals to 1. So what will be the next solution? Minus 2 minus 1. Yes, try that. Minus 2 into minus 1. Again 2. Minus 2 here square means the same answer. Minus 1 square means same answer. Yes. So we found the answer. So how did we find the answer? We'll check this xy, that is 2. Then we found the 2, the factors of the 2. It can be 2 comma 1 or 1 comma 2 or root 2 into root 2. These are the things you have to check. Only whole numbers you have to check here. If it's a whole number. If it's 2, you have to check whether 2 and 1 and 1 and 2. Okay. And root 2 and root 2. Okay. So what is the final answer? So answer is that x plus iy of 2 plus I or minus 2 minus I. So how did you get this one? After getting the first one, you multiply the first answers by the minus and put it here. If it's 2 and 1, put minus 1, minus 2, minus 1. If it's minus 2 and 1, put 2 and minus 1. Understood? So whatever here, the first answer, you multiply it by minus and put it down. Okay. So that's it. So if you are not able to get in this method by guessing and getting, so then you can proceed with your substitution and finding the x to the power 4 and everything. You enjoy that. Okay. So please do it. If you are able to do, then no problem. Okay, guys. So can you do this? Is one example. Finding the square root is an example, right? I'll give exercise. So the next question is, that is exercise now. Now exercise. So question number 1, finding square root of 3 minus 4i. Let's do I go for the different one. 5 minus 12i. Just do it. I'm not going to erase this one because I know that it's there. I will erase this. I will erase this. I will erase this. I will erase this. And I will erase this one also. Since you know how to get the answer, that's the way. It's easy, always easy. Don't believe that confinement is hard. The way you learn may be hard, but not here. So z equal x plus iy. Then z squared. Z squared. Okay, please do it. I can do. Z equals square root. Let z equal x plus iy. Z square equals 5 minus 12i. That is x plus iy again 5 minus 12i. 5 minus 12i. If you equate the coefficient, not coefficient, real part of complex number, here 5. Imaginary part of that minus 12, then in minus 6. Okay, now it's your turn. Anyone? Anyone got the answer? At least one solution or one value for x. You can type, or you can type one answer come by putting comma or plus also you can type. Anyone got the answer? 6. 6 means don't consider minus now. First consider 6. Multiplication is 6. If you multiply two number, it becomes the value is 6. It's okay, minus. But a square of this, that is 5. So 3 and 2 might be good. But 1 must be minus because minus 6, no? So here is a positive number. So x must be greater than y. So you have to give 3 for x and minus 2 for y. First one. You can give like that. Yes. 3 and 2. And 3 squared is 9. 2 squared is 4. Yes, that's satisfied. So 3 and 2. The problem is the minus is there. So I put minus for x first. Then I multiply the both numbers by minus and put for the next solution. So z will be minus 3 plus 2i or plus 3 minus 2i. That's it. Hopefully. So guys, exercise 2. Now I erase this. Exercise 2. Z equals, this up to you. So let's see. Minus 3 plus 4i. Let's see how you can do this. Minus 3 plus 4i. So I erase this part. I erase this red part, red. Since I have the formats, I am going to erase this one and this one also, and this one also. Right? Please do that one. How you are going to do, let's see. Let me know. Finding the square root of the complex numbers, easiest ever. Okay, hopefully you have done that. Let's see, some students they have done. They said -1 and 2. Let's see. So you are there. So hope you understood, right? How to do that. So then this is okay. Z square is -3 plus 4i -3 plus 4i and -3 plus 4i. Then if you expand that -3 plus 4i, if you equate this, that is -3, this is 4, this is 2. So actually, this is minus me. That means x must be less than y. And xy is 2, then you can select 2 and 1. Check that put 1 for x and 2 for y and say, that's correct. Because 1 minus 4 is -3, correct. So 1 for x and 2 for y. At the same time, you might multiply those values by minus and put. That is the other value. So the one solution is 1 plus 2y or -1 minus 2y. Is it clear? Right? Okay. So now I am going to give bit challenging one. Let's see how you can do that. So square root of 12 minus 5i. Bit challenging. Not only plus, I put minus. 12 minus 5i. It is this. But for you, you have to write. I can erase and fill because the format is there. But every time you have to write. Now you are okay with this. You can equate x square minus y square to 12, x 2xy to -5. So these are the things you need to know now. Anyone? I'll give some time. Maybe you will be okay. During that time, I can fill the ink. Yes. Think and do, think and do. Okay, it seems to be bit hard, but it's not actually. Listen how to do this. This is no problem, okay, at all. You know, that is 12 minus 5i, no problem at all. And 12 minus 5i, no. 12 minus 5i, then x squared minus y squared is 12. This is minus 5. The problem is xy is minus 5 by 2. So now it's difficult to find x and y. So you can't guess, right? That's a thing because you are having the denominator that is 2. It's a fraction. But still we are able to do. Still I can help you without going for the x to the power 4, the fourth uh, power equation, right? How? The guys, please listen to you. So in normally in simultaneous equations, have you noticed that x and y, right? Those uh, unknowns, right? You are going to solve that unknowns. So usually, have you noticed that x and y having same denominator, right? Okay. So same denominator. Denominator must be same, right? So most of the time you have noticed, I think so. So then I'm going to use the technique. So x and y having same denominator means this 2 must be divided into 2 equal portions. So if anything comes, what we have to do is you have to consider the it is 2 root 2 root 2, right? You can consider root 2 root 2. Why? If you multiply this only, you will be getting 2. And it must be equal means there is no other option. It is going to be root 2 root 2. If it's 4, then you can put 2. But this is root to the 2, no? Then you have to put root 2 root 2. So the denominator is root 2. First, you can decide that one. So denominator is root 2, right? Root 2, root 2. Now don't worry about anything. Just consider 5. How can you find the factors of 5? 5 is a prime number, right? You are going to find only what it means for 2 factors. That means 5 and 1. So just put 5 here. This is 12, no? Positive, no? Put 5 here, 1 here. And substitute here and see. What do you get? 25 by 2. If you substitute 5 by 12 here, minus 1 by 2, that is 24 by 2, that is 12. Are you getting? Yes, you are getting. So then our answer 5 by root 2 and 1 by root 2. But here is negative, no? So you can put negative for this one first and next one. So for the next value, that one. Okay. So we'll start with that. So that is the easiest way to do. So once we end up with the fraction, first check with this whether you are able to do with this root 2, and if it's 3, root 3, root 3. Okay. So this is going to be 5 by root 2. I put minus, and this must be plus. And I multiply both by minus, then this is minus. So answer is minus 5 by root 2 plus 1 by root 2 I, or 5 by root 2 minus 1 by root 2 I. Okay, is it clear? So I will explain again what happened. So this is okay. So when you come to this and this, so you end up with a fraction. So there is a number 2 in the bottom as a denominator. So hereafter, most of the students, or 100% of students, I think, right? So 99.9% of students, they leave. So most of the students, they won't do in this method also. And among them, so they leave because they see this is 5 by root 2 cannot be done, right? So what you can do, so how you are very sure about that you can do in this method? So how I am very sure about that I can do in this method? because Pythagoras numbers here, 12 and 5 are Pythagoras numbers. 12 squared plus 5 squared and square root is the whole number. So 3 and 4, yes. So if you end up with those kind of things, so definitely you can do this kind of, right? So you understood. So that's right. That is the main reason, right? So now you can check. So initially, if it's not coming like that, then you can immediately, you don't need to check in this method. You can go in a normal way. But anyhow, it's not. If you have the time to check, please do it. Okay, so the exercise 4, I'm going to give this time. You're okay. Anything you can do. But for that, I'm going to give not 12 minus 5i. I give minus 4 minus 3. How you are going to do this one? Okay, others please copy this. Others please copy this. This nice one, right? Finding square root of complex numbers. Today's special. Right. Finding square root of complex numbers. Right. Okay, so it is this part, and this part, and this part, this part. Done? Anyone? Done? So let me know once you are done. Right. So as the answer, uh, you can't type, no? Sometimes you will find the square root and everything in the answer, right? Okay. Anyhow. Guys, right? So we'll do this. Z squared is minus 4 minus 3i. Right. Minus 4 minus 3i. Minus 4 minus 3i. Then this is minus 4, this is minus 3, this is minus 3 by 2. Okay, everything okay, no problem. We found that 3 by 2, so first we'll consider the value, not the minus. Later we can deal with the minus. So 3 by 2 means most probably so this is root 2 down, and 3 you can put 3 and 1. But here you have minus, that means x value must be smaller than y value. So it is better to put 1 over root 2 and 3 over root 2. So 1 over root 2 for x and 3 over root 2 for y. Check that half minus 9 by 2 minus 8 by 2 is minus 4. Correct, correct. So then these are the values, but you have minus here. Then put 1 minus, then minus 1 over root 2 and 3 over root 2 and 1 over root 2 minus 3 over root 2. So answer is 1 over root 2, 3 over root 2 I, or 1 over root 2 minus 3 over root 2 I. Is it clear? Is it clear? Is it clear? So that's it. Right. So now quickly you have to do the past paper question, 2009 past paper. 2009. So I erase this. 2009 past paper. I can put on the board, but it is better to write, I think. So 2009 past paper. 2009 A-level. Okay. So it says find the square root of the complex number. Right now, find the square root of the complex number. Minus 80 minus 18i. Find the square root of the complex number minus 80 minus 18i and solve the quadratic equation. And solve the quadratic equation. Just copy this. Okay. And solve the quadratic equations. 4z squared plus 16i minus 4 into z plus 65 plus 10i equals 0. Okay. So that's it. So write down first the equation. 2009 A-level question A part. A part means second there. There is a essay question, right? Essay question. There are 3 portions. So this A part is find the square root of roots of the complex number minus 80 minus 89. Minus 80 minus 89. Right? And solve the quadratic equation. This. Just do it. Just do it. Hope you will do. Okay, so complex numbers will be easier one. Let's start from the beginning. We will hope you have done that square root of this, right? Yes, yes or no? Right. First of all right, you see z equals minus 80 minus 18i, and let's the square root of that, and let z equal x plus iy. So z squared equals minus 80 minus 18i. That means x plus iy whole thing squared equals minus 80 minus 18i. Then x squared minus y squared plus 2xyi will be minus 80 minus 18i. Then equate the real part. So x squared minus y squared equals minus 80. Equate the imaginary parts. 2xy that equals minus 18. So xy will be minus 9. Second equation actually. Minus 9. That is the second one. Okay. So now, so we put x and y. Now we know that minus 9 is a number. Minus 9, you can think 1 and 9 and 3 and 3. Is it possible 3 and 3? No. If 3 and 3, it becomes 0. Say 9 and 1. So 9 squared is 81. 1 squared is 181 minus 180. Yes, of course. 9 and 1 is correct. So 9 and 1, but this is minus. So x is positive, x this is negative. So other way around. 1 here and 9 here. Smaller, x is smaller than y. That's why you get negative. And this is minus, then put minus for 1 and multiply it by minus and put it down. 1 minus 9. So solutions are minus 1 plus 9i or 1 minus 9. That's it. Hope you got this. You have to. You have to. Okay. So then what they say, you have to solve this quadratic equation. So I'm going to erase this. Before that, you copy that. So I'm going to erase this. Before that, you have to copy it. Right. Right. Okay, guys. Right. We will do this one. So answer for the square root of this is minus 1 plus 9i or 1 minus 9i. So I erase this part. And this part. So now I'm going to solve this quadratic one. Since it seems to be I can't factorize this. It's very difficult. So I'm going to use the formula. You know the formula. So z equals minus b. Minus b means there is a minus. Shall I write without putting minus in front of this? Shall I write 4 minus 69? This is b. Minus b is 4 minus 69. Shall I write like that? Plus or minus square root of r. B squared 16I minus 4 whole thing squared. B squared minus 4a. See, 4 minus 4. A is again 4 dot 4. C is 65 plus 10. Clear? Over 2a. That is 2 into 4, 8. Is it clear? By using the formula. Then I have to simplify this. How to simplify? I'll tell you one technique. If you use the technique, you will simplify easily. So what you can do, inside this square, inside that, take the 4 out. Then outside this square, it will be 16. Do you understand? Inside 16I minus 4, all things square, no? Inside that, if you take the 4 as a common, if it's come to the outside, it will be 16. So this will be 4. This will be 1 if you take the 4 out. Is it clear? So this is 16 into 4I minus 1. Like here also you have 16. So that 16, if you take it out, outside the square root, this will be 4. That's 4, and this 16, this 4, and this 8 you can cancel. So that is a plan. One step I am going to do this. Since this is simplification now, so I put this z equals minus 1 plus 9i or 1 minus 9. Okay. Right. So my plan is okay, right? So I'm taking 4 out from here. Then out of the square, it will be 16. Then I took the 16 out. Then out of the square root, it will be 4. Then this 4 and 16 and 4 and 8, I can cancel. So what I get? I get 2, I get 1, I get 4i, and plus or minus square root. I get 4i minus 1 square minus 65 minus 10i. That's it. So using the quick process, you have to simplify that. Now it's it. Now how is it? So now you expand that. That is first 1 minus 4i plus or minus square root of. Here if you expand that's minus 16. 4i squared means minus 16. Then plus 1. So minus 16 plus 1 means this square. Minus 15. That minus 15 and minus 65 is minus 80. So I did this one and this one square and I added with this. That's all. Then the middle term is minus 8i and minus 10i. Minus 8i plus minus 10i is minus 18i. Have you seen this guy before? Have you seen this guy before? This minus 80 and minus 89? Have you seen this guy? Yes, that one. The square root of that. So there are two values. So already you have plus or minus here. So take at least one, or take only one value. So if you take two values, again you are going to get 2. That's okay. Even if you get two values also, no problem. But it's better to get one value because already you have plus or minus in front of that. So you can choose one value from there for square root of this. So 1 minus 4, right? If you put plus or minus here, I can take 1 minus 9. That is best for me. So if I take plus, then z will be, if I take plus 1 plus 1, 2, and minus 9i minus 4i minus 13i by 2. So complex number language 1 minus 13 by 2i. If you take minus, this one and this one will be cancelled. This become plus 9i minus 4i 5i. So it's going to be 5i by 2. 0 plus 5 by 2i. Is it clear? Z equals. If you take the minus, Z will be 0 plus 5 by 2i. Is it clear? Z equals 0 plus 5 by 2i. If you take the minus, Z equals 0. So there are two solutions, 1 minus 13 by 2i and 0 plus 5 by 2i. So that is the end of a part of the 2009 past paper. Understood? Any doubts? Let's see. Some students, no doubts. Okay, that's fine. If you have no doubts, that's fine always. Right. Okay. So put the heading quickly. Cubic root of unity. Cubic root of unity. So put the heading. That is that cube is equals 1 we have to solve. Cubic root of unity. After writing this, put the heading cubic root of unity. So in the map, I have given the map at the beginning of this complex number class. So you can see in the map where we are right now and how many topics are there to finish under the complex number. So you know the map, that is simplification and Argand simplification and Argand diagram and mod of z argument of z and r into cos theta plus I sin theta form. The square equal k, that means square root of this. The next set cube is equals to 1, that means cubic root of the unity. And the non-real roots of the quadratic equation we have to learn it after. After the locus, then rotational rule, then we will learn De Moivre's theorem. So that is the end of the complex number. So complex number is not going to be a challenging part. That's it's easy. Always we know we have finished matrices. So we are completely finishing that. So only remaining bar in pure mathematics is circle, right? And binomial expansion, that's all. And binomial expansion, have you done that permutation and combination? Not yet, not yet, isn't it? Permutation and combination, did we do? Have you done that? No, okay, that's part. That's the easy small chapters are there. Okay, no problem. Right. Okay, so put the heading, cubic roots of unity. It is so cubic roots of unity. Cubic roots of unity. So cubic roots of unity, right? And it is this part also. Hopefully you have done. So that means 1 to the power 1/3. That equals 1 to the power 1. How many roots you can find for 1 to the power 1/3? There are 3 roots. So obviously you know the one root is 1. Another 2 roots are complex, right? So we are going to find that. Okay, so consider right now, consider z cube equals 1. So because I have to solve for z equals 1/3, so z cube equals 1. So what I am trying to do is I will factorize and I will find the roots. Okay. So that means you can consider, consider. Okay, guys, so I erase this one also. Right, so you bring the 1 to this side and make it factors z squared plus z plus 1 equals 0. Then you know that z equals 1 or Z squared plus Z plus 1 equals 0. Did I erase this? I erase this. And I erase this and this and this. So here I can use the formula to find this minus b plus 4 minus root of b squared minus 4ac over 2b. So z equals 1 or z equals here minus 1 by 2 plus or minus. This is root 3I by 2. So you can find minus half plus root 3 by 2I and minus half minus root 3 by 2I. So there are solutions. So roots are, write down roots are 1 comma minus half plus root 3 by 2I minus half minus root 3 by 2I. So these are the roots. Is it clear? So how you can say, in other words, 1 comma, if I say this is omega bar. If I consider this as omega, this is omega bar. You know that's conjugate of this. And you may ask me, oh, then sir, if I consider this as omega, then this is omega bar. That's it. Oh, that's right. Okay. So please write down quickly. Hurry up, hurry up, hurry up. Hurry up, hurry up. Quickly you have to write down. Quick, 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 quick. Quick, 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 quick. Okay. So it is this very important one. So now you can say 1 comma omega bar are roots of z cube minus 1 equals 0. Yes, no? You know what is omega? Omega, you can take it anything here. Right? So show that right now, show that omega bar equals omega square. Omega bar equals omega square. If you want, you can put if in front of this, make it as a question. Show that omega bar equals omega square. Can you try that? Can you try that? Omega bar equals omega square. How to show that? Can you try? So normal method is okay. I'll normal method is so the normal method is so you say you have to find that you have to do z cube equals 1, you know, z minus 1 into z squared plus z plus 1 equals 0, then z equals 1 o, z equals minus half plus o minus root 3 by 2 I. You have to do like that. Again, you have to do if you want to show that. It's a normal method. So let omega bar will be uh, uh, okay, so let omega is minus half plus root 3 by 2I. Then omega squared will be minus half plus root 3 by 2I whole thing squared. So you can expand that. That is 1/4 and this square and that square minus 3/4. Then minus this into this root 3/2. I so it's going to be minus half minus root 3/2 I, which is omega bar, which is omega bar, right? Which is omega bar. So you can prove that like that. Okay. So I will prove in a different methods. That's a short, easy method. So this is the normal method what students they do. They find one root and they square and they simplify and they show that this is the other root. That is omega bar. Right. So I go for the quickly write. Quickly write. I'll give some time. Quickly write. Okay, so we will do this one. Right. Okay, so there is another method two, to prove this, right? So there is an easy way to prove. So method two, right? So it is method two. So method two is you have to prove omega here, one omega bar are the roots of this. That is okay. You have to prove this omega bar is omega squared, isn't it? So what you can do there is, you know z cube minus one, and you know z minus one into z squared plus z plus one equals 0. So then this is Z equals 1. And what you can say, you can go there. Oh, no, 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 no. You can go there. No. Go. Ah, ah, go to there. Oh my goodness. It's give me a second. There's my dog. Guys, wait 1 minute. I'll be back. Okay, guys. So actually, there's a room, right? Okay. I think I can adjust this. Okay. Slightly okay, right? No problem. So, and here, O, that is O. Here, omega and omega bar are roots of this z squared plus z plus 1 equals 0, isn't it? Here, 1 is the root here. It came from here. Then omega comma omega bar must be roots of this equation. So you can prove that, okay, then omega into omega bar, that is product of the root. Product of the root is C over A, that is 1. Product of the root is C over A, that is 1. But you know that omega is root of this one also. 1 also root of this equation. Omega bar also root of this equation. Omega also root of this equation. So, but omega cube equals 1. Why? Since omega is a root of it. So, instead of 1, I put omega cube. So, omega bar, that is equal to omega cube. 1 omega cancels. So, omega bar equals omega square. Understood? So, that's the easy way. So what you can do, so omega into omega bar, product of the root C over A, and but omega cube equals 1 because you can substitute the omega here since omega solve this equation. So omega cube equals 1. So omega into omega bar equals omega cube. So omega bar equals omega square. Clear? And I wish to say method 3, that is also the best. Okay. So method 3. Technical and technical methods. So shall I explain this again? Okay, I will explain this. So this is the very fundamental things because 1 comma omega bar are the roots of this equation. Okay. Okay, please listen that. Okay, don't go away. Then I factorize this and I got z equals 1 and z squared plus z plus 1 equals 0. Then 1 is the root came from here. So then omega comma omega bar must be roots of this quadratic equation because 1 already came. So omega comma omega bar are the roots of this quadratic equation. So that is now I have done the quadratic equation now. So since omega and omega bar are the roots of the quadratic equation, So I took summation of root, not summation of the root. I took product of the root. Product of the root, PR, product of the root. If I take that is product of the root, so product of the root is C over A, 1. That's okay. Then I saw that omega cube equals 1. Why? Omega is the root of this equation. Here you can substitute 1 and see 1 minus 1, 0. You can substitute omega there. So omega cube equals 1. If you want, you can substitute omega bar also there. So I took omega cube equals 1. So instead of this one, I put omega cube. So 1 omega is cancelled. So omega bar is omega squared. So that is the concept behind this. Is it clear? Is it clear? Is it clear? Right. So method 3. Method 3. That is more technical than this. Using the method 3, you can prove that omega bar equals to omega to the n naught. Not only for square or cube or anything. You can prove that omega bar equals omega to the power n, anything, using method 3. So, but I am not going to prove that one. I am going to prove this one. How to prove this? See, first of all, you know, since omega is root of z cube minus 1 equals 0, omega cube equals 1. So first statement is okay. This is okay, no? Right. I erase this part. I erase this part. I erase this part. Say now I say here, consider I consider this equation, z expression z cube minus 1. I consider z cube minus 1. Okay. So I'm going to put z equals omega square. I'm going to put z equals omega square. Yeah. Whether it's going omega square solves this equation. So that omega square cube minus 1, this will be, then I can write omega cube squared minus 1. I know that omega squared cube can be written as omega cube squared. Omega cube equals 1. So 1 squared minus 1, 0. So omega squared also root of z cube minus 1 equals 0. Is it clear? So then what is omega cube also root means? I know 1 is the root and I know omega is the root. And we say now omega squared also root means that omega bar must be omega squared, because you have to have only 3 roots. You need to have only 3 roots and 2 roots you know, and it says omega, another root one is omega squared, then that must be equal to omega bar. Is it clear? So we know one root, 1 is there, that is always there. Omega is the root we took. And we have shown that omega squared also root. Then omega squared must be equal to omega bar. So finally what we decide, cubic roots of the unity. Write down, put this exam tips and write down. Exam tips and put exam tips and write down. 1 comma omega squared now. Now we don't put omega bar. So rather than putting omega bar, we put omega squared r roots of z cube minus 1 equals 0. Okay, then there are famous 2 results you need to memorize. One is omega cube equals 1 always. Like in quadratic equation, you memorize alpha plus beta minus b over a, alpha beta c over a. Those 2 things you memorize, no? You can obtain also, but you memorize, right? Alpha plus beta minus b over a, alpha beta c over a. Likewise, here also you have to memorize 2 things. That is omega cube equals 1 and Next one, 1 plus omega squared equals 2. This is okay. You are okay with this. Then what is this? Actually, you know that this is omega is root of z squared plus z plus 1 equals 0. No? Omega comma now omega squared. These are root of this equation. No? Then you can substitute omega here. Then you will obtain omega squared plus omega plus 1 will be 0. So important factor that we have to keep it in your mind whatsoever. So these things you have to use. Okay. So omega cube equals 1 and 1 plus omega squared equals 0. So using this, there are more simplification. Sometimes they may ask you to simplify omega plus 1 whole thing to the power 5. Right? Then instead of that, you have to put minus omega squared here and you have to simplify. So there are many questions like that. Okay. So I hope I can do that tomorrow. We will do that tomorrow, not now. So simplifying, just using the simplification and everything related to unique cubic thing in past paper questions. And then we will move to locus immediate. Okay. Is it clear? So today I'm going to conclude the class right now, right? So tomorrow we will be we'll be continuing. So tomorrow also class, I think it's early morning 6 is not possible for someone or for me. Myself is okay because I put the message at 6 o'clock, so I can just start the class any time, right? So if you all are okay, then I can start 6 o'clock, or if you're convenient is 6:15 or 6:30, we can do like that. So let me know, guys. Okay.